know the demands of the world are rapidly changing, and the agriculture industry evolves to meet those demands. So digital twin technology offers a sustainable path forward, mitigating climate-fraught risk by optimizing and increasing the efficiency of agriculture processes. So in this event, we will delve into transformative potential of digital twins within the agri-food sector, benefits of implementing a digital twin tool to enhance decision-making in agri-food value chains, and role of blockchain technology in ensuring traceability and transparency. So we have 4 wonderful speakers ready for you today. And first speaker, we will have Daniel de la Puente Ranea, but we have also Rebecca Martinez de Laguna Martinez from Pano Imogen. Then we have Israel Serrano from Stelbiotech, and Jose Maria Alonso Rodriguez Cacho from Soltec Ingenierías. So first, I will give the floor to Daniel de la Puente Ranea, who is head of EU projects at National Center for Food Technology and Safety, and he will be speaking about transformative digitalization in the food industry. Daniel, happy to give the floor to you.
Yeah, thanks, Daria, for the intro. And then good morning, everyone. Thanks for being here today. My name is Daniel, and I coordinate BBTWINS. And let's get started. So next slide, please. And some of you may remember the slogan from a tire brand that was pretty popular in 1995 and featured Olympic medalist Carl Lewis, known for his 100-meter world records. And this ad has him wearing heels, right? So the idea was very simple. A car can be very powerful, but without good tires, the power cannot be controlled. So we believe the same thing happens with digital transformation. The theoretical potential is enormous, but without practical applications that are grounded to concrete reality and generating specific benefits, in exchange always for a cost, the potential is useless. Next slide, please. Do you guys hear me? Yeah. So yeah. And so precisely these practical applications are the basis of BBTWINS, which is, as Daria said, a digital twin technology applied to 2 specific cases, pork and pigeons. A digital twin is no more than a real-time digital replica of a physical process. So what we've done with these specific use cases is an initial diagnosis of these 2 production chains, and we identified specific needs and problems that we have solved, combining sensors, combining process modeling, combining logistic analysis, big data, artificial intelligence by machine learning, and blockchain. Next slide, please, to start with the first use case, which is the pork use case. So let's imagine we are a food industry and we raise our own pigs in 80 breeding and fattening farms with about 200,000 pigs carefully fed and raised until they reach approximately 120 kilograms. So the question is, how do we know that 200,000 pigs have reached that size? Next slide. So of course, as you see on the left, weighing one by one on a scale and then spraying like markings to show their status is not an option. If it took like 3 minutes only to weigh each pig, it would take us 418 days, that is more than a year, working around the clock to weigh them all. And that's only assuming we weigh them once during their life, which is not very useful for monitoring purposes. So today, as you see on the right, this is done by a qualified operator who chooses and marks the pigs after a visual inspection, a visual evaluation, because when the calendar weeks approach, in which it is estimated that the pigs have reached that weight. So, the operator goes there and chooses the right animals. So therefore, the actual variability of the product is relatively high. For example, the weight of the shoulders or legs of cured ham varies significantly. So basically, to know how we solved it, Panoimagen in no time will explain it. So please stay with us. Now we're seeing the other case study, which is peaches and nectarines. So to have a good yield, there are many factors that we must control, of course, but one of the most important is the initial number of flowers and the resultant number of fruits per tree. So since the tree has a limited capacity to feed those fruits, if there are many peaches, we will have plenty of them, but they will be very small. And if there are too few peaches, they would be very large and they may look too expensive to us as consumers. So what's the perfect amount of them? Also in this case, the estimation is done visually by trained people. So again, stay with us for a little longer, and then Rebecca will show us, how we solve that. The next slide, with the next slide, we go back to the meat industry, specifically to a very verticalized production chain that includes and their own feed factory with 130,000 tons per year of feed, which is produced and distributed to around 80 farms, as we said, feeding 200,000 pigs that give 18,000 tons of fresh pork meat and more or less 18,000 cured ham and shoulders. And this is all in a production process with inputs, outputs along more than 275 productive steps. So being so huge, so complicated, how do we ensure internal traceability? Or what's more, how do we show the consumer that we care? How do we convince them that we are doing it right with so much labeling and greenwashing around? So Stelvio will very soon unravel it. And finally, as an intro, well, the integration of these technologies is not without challenges, of course, and this is when teamwork comes in. It also requires significant investment in both technology and training, as well as a thoughtful approach to data privacy and workforce adaptation, in particular, like the impact of employment and the necessary skills to make that transition. So, well, again, thanks for being here today. I'll leave you with my colleagues who will tell you our own approach to solve these challenges.
Daniel, thank you very much for this presentation. Thank you.
My pleasure.
So again, if audience have any questions, you can put it into the Zoom chat, or again, you can wait until the Q&A part after all the presentations are done. So next up, we will give the floor to Rebecca Martinez de Laguna Martinez, who is R&D engineer at Panoimagen. She will talk about AI-driven. Yes, Rebecca, do you want to?
Hello.
Yes.
I'm glad to be here with all of you.
Perfect. So Rebecca will speak about AI-driven digital solutions addressing real-world challenges in the agri-food sector, and with the focus on enhancing the efficiency and effectiveness of process modeling and logistics through advanced data analysis and AI. So Rebecca, happy to give the floor to you.
Okay. Can you next slide, please? Okay. The agri-food sector faces significant challenges in improving the efficiency and sustainability of its processes. Within the BBTWINS project, we have developed possible solutions related to the production of pigs and peaches, using new technologies such as artificial intelligence as the main objective of improving the value chain. Our approach begins by collecting data with high automation. Afterwards, we analyze the information to identify and choose the optimal algorithms for our purposes. And finally, we develop the corresponding model. Next, please. Well, different problems arise in this sector. Here are 4 of the most common potential challenges. The first one is ensuring optimal environmental conditions for crop growth, such as temperature, humidity, and soil quality. A good solution for this is the installation of sensors, which can collect real-time data, and it can be analyzed to provide accurate data and recommendations on effective crop management practices. The second, timely detections of diseases in crops is critical to prevent yield losses. In this case, by integrating satellite imagery and drone technology allows for detailed monitoring of crop health. And by applying AI algorithms trying to recognize patterns, we can be able to mitigate risks and protect crop yields. The next challenge is the automation of manual tasks on the production line in food industry. The proposed solution is to use artificial vision to examine the product at that point in the chain and create an application that replicates the process carried out. And the last challenge consists of maintaining food quality and safety standards across the supply chain. Deploying sensors enables continuous monitoring of critical factors and flagging potential risks. Next, please. Okay. Capture data is essential as input for algorithms. On one hand, we use sensors placed in the field to obtain environmental information, as in the case of Dimitra. These sensors are connected to a LoRaWAN gateway through which the data reaches a cloud database. And on the other hand, we utilize real-sense cameras or LiDAR laser devices, which supply us the values crucial for our mathematical computations. And then, before applying algorithms, it is fundamental to understand and prepare the data to ensure accurate and meaningful results. To achieve this, initially, we carry out data cleaning, which involves removing irrelevant, duplicate, or inconsistent information. Next, depending on the type of data, it's necessary to perform some transformations and explorations. This includes various types of analysis, such as statistical, time series, or clustering. And once this phase is completed, we have the data ready for modeling. Next, please. Okay. For Dimitra peach orchards, we train a model using an object detection algorithm to locate blossoms or peaches on the trees, depending on the time of year, and then process it with another tracking algorithm. The result is an approximate count considering 13 losses, such as peaches covered by leaves or areas that are difficult to capture. Moreover, we also perform 3D reconstructions, and that in this case, we start from two-dimensional images to which we apply neural radiation fields to estimate the radiance at three-dimensional points in a sense from multiple ways. And in addition, we also experimented with SLAM techniques, enable us to visualize the recorded path. Next, please. Okay. Now, I will show two models that we have developed with Portesa. For the first application, we made a prediction of the pig weights within the farm by capturing the image of the pig, which is later processed on the cloud server and returns the estimated weight value on the screen. To achieve this model, we have used a device with a pulse lidar laser for data capture, which allows determining the distance from the emitter to the animal. With this, we can create images of more than 3 channels with depth information and assign them to the corresponding weight of each piece for training and validating with neural networks. The second application is focused on measuring distances. In this case, a specific area of the thickness in pig carcasses. In this case, we use semantic segmentation to locate the area and then apply different artificial vision methods in order to fine-tune the detection and use mathematical calculation to convert pixels to real world. Next, please. Okay. The application of the above technologies can offer the following advantages. The first, enhance productivity and efficiency. The model for predicting pig weight on farms can assist farmers in better managing animal feeding and care, resulting in faster growth and more efficient production. It can also help in the task of selecting of animals by weight range. Another advantage is harvest optimization. The model for counting pitches in a tree plot can provide farmers with an accurate estimate of fruit quantity in the field, aiding in better harvest planning and distribution. And as the following cost and waste reduction, by predicting pig weight more accurately, farmers can avoid overfeeding, reducing feed costs and minimizing waste, and the same for fruit. Second, informed decision making. Data collected by AI models can provide valuable insights for strategic decision making, such as crop selection, harvest scheduling, and inventory management. And the last, product quality improvement. By closely monitoring pig growth and health, as well as pig tree health, workers can intervene quickly to address health or stress issues, resulting in better meat and fruit quality. Next, please. This is the end of my presentation. I hope you enjoy it, and thank you very much for your attention.
Rebecca, thank you very much. If you allow, I will ask one question before we move on. So can you tell what is the most complex part of the entire process from data collection to validation of the final model?
Yes, in my opinion, I think the most complex part is the training and validation of the final models, because it requires knowing aspects from the architecture of the neural networks to the real world conditions to validate in situ and have everything balanced and without errors. So in addition, it's really computationally complex as well. And there are a lot of aspects. Yes.
Okay, I can imagine. Okay, thank you. Thank you very much for answering this and for your presentation.
Okay, thank you.
All right, so we are moving on now to next speaker, Israel Serrano, who is CEO and founder at Stelbiotech. So he will be talking about the verification of sustainability and traceability through blockchain technology and highlighting the successful deployment of a blockchain for tracing products and biomass within the agri-food sector. So Isra, happy to give the floor to you.
Thank you, Dalia. So I move to the next slide because it was just the introduction. Thank you, everybody, to be here with us today. So, the world is moving and there are a lot of pressure from the consumers to produce more sustainable, to track all the origin of the product, and to get more information about the food that we are consuming. So companies are the drive change in the food system that are drive by the consumer's demand, basically. If we move to the next slide, we will see some of the challenges that the consumers, the producers has already due to the increase of this sustainability and sustainable demands and tracking demands. In fact, in Europe, we have a really strict regulation in terms of food safety and food security. But the world is not just Europe. So there are continents like Latin America, North America, Asia, especially with China, is the demanding is being very high or has increased by 2 digits in the last 5-7 years. So basically 94% of the consumers are likely to be loyal to a brand that offers complete transparency of their products. These are the sources are from the Label Insights Transparency Study, European Commission Farm to Fork Strategy, and Food and Agriculture Organization for the FAO. No? So it's really, this is really a tendency, and 34% of consumers are able to pay even more. So the sustainable demand for organic bioproducts is growing by a double digit, and the CIGR will be at 10.5% of the total production by 2027. So the producers, the food producers, are struggling to demonstrate their credibility, no? Because there are no verifiable systems to show that. Also, another problem that they have is the inefficiencies and waste that we are aiming to achieve and improve the reduction of the waste in the BBTWINS projects with the different colleagues here, specifically with the biomass sensors and IoT integration, and with the information provided by the digital twin. So 14% of the world's food is lost because of the post-harvest. So once that the fruit is harvesting, is lost. 40% is a huge amount of food. And there are an increase on sustainable demand as the consumer. There is a recent study, it took place in 7 countries, US, Germany, China, Japan, and Canada, if I remember correctly, where 34% of the people are really demanding more information about how sustainable is that food product. This is really significant, and this is some of the problems that the food producers are facing nowadays, and they have to provide, let's say, a solution or an answer to that consumer demand. So if we move to the next slide, we will see that what we have created in our, let's say, solution, or how we can solve that, how we can help the food producer with this is enhancing the farm to fork traceability and adding some indicators on sustainability. So enabling those farmers and food producers to show the best practice and to give the impact, the positive impact that they are doing. So basically, what we are creating is helping them to increase the consumers' demand and helping them to give information to the consumers to have a better decision, more healthy on the origin, on the product itself, and how the product has been produced, not only with with environmental impact, but also with economical and social impact. So, of course, by having a traceability farm to fork aligned with the European Union policy and regulation, we reduce by 70% because sometimes you have to be realistic. Sometimes you don't have enough information to cover all the value chain, but it reduced by a significant amount the opacity in all the supply chains from the production to the consumer, where the consumer buy that product in the retail. And we helped, together with the combination of those technologies, sensoring in the field, sensoring in the farms, and the digital twin and the traceability, to reduce the waste, because you have more and better data to make decisions on what is happening inside your supply chain. And then all of these, or part of this, is helping to the corporate reporting. So recently has been published I think the last 3 years, if I remember correctly, the Corporate Sustainability Reporting Directive. And we help those food producers and farmers to be in compliance with the regulation. So we help them to provide some of the information on part of the reports to be according to what is demanded by the directive, the CSR directive. So if we move to the next slide, basically what we have been done is made up of several components. We have a sustainability module where we are measuring and scoring some KPIs. We enable community engagement by being involved the consumer with they can measure their scoring, sustainability scoring, and we intend to be providing certificates. So this will help the farmers and food producers to show those best practice and engage the consumer, showing that best practice to them. We have also the farm to fork traceability. So it increases the transparency, makes the proof of origin in your hand. You can verify from where the product has been harvested or collected or produced. That is very relevant, especially for the consumers in the Northern Europe. Probably not. You know that in Estonia, that is very, very demanding, that information where the product has been produced. The same here in Germany. So we have also providing the farmers with data-driven insights with some of the real data monitoring and optimization and predictive analytics. They will be able to make better decisions based on the data that they collect, and the regulatory compliance model with all the reports. And we save time to the producers and enabling them to focus on the quality. If we move to the next slide. So basically, this solution is a platform, is a cloud platform, where in a very easy way the food producers can organize the traceability and can have in one single place all the traceability information. And this is due to the blockchain technology. So the benefits of the technology in this case for the supply chain is we keep all the data in one single source of truth that cannot be manipulated. So it's like if the farmers or the logistic operators or the distributor, they have the information in silos. With this solution, we collect all the information, all the data from the different steps in the value chain, and those data, once that is loaded into the solution into the blockchain, as I said, cannot be manipulated. So the difference between a normal database and a blockchain-based persistence layer is that in a normal database, you can load, delete, and modify data. But in a blockchain layer, DLT, you can only read and write. So you cannot delete some data, you cannot modify some data. So it proves the information that is not manipulated. So basically, you cannot change the date of production, you cannot change the date of expiration of the product, and so it gives more transparency and trust to all the actors in the value chain and also the consumer. At the end of the day, the fruit is produced to be consumed by us. So also as we are creating an app to retrieve all of this information to the consumer, that they even it's not just traceability, it's proof of origin, and we want to give them a healthy recommendation or to have a better and healthier food aligned with the European Union strategy to make to give information to the consumer to make healthier decisions. So if we move to the next slide, and we're about to end. So the work is very simple. We collect data from different solutions like Panoimagen is uploading, or ERPs, or the information that is internally into the company system. The consumers can verify that information, and the consumers receive rewards or incentives by retrieving those information from the products that they are consuming, and then we increase the collaboration and the consumer engagement by giving incentives or participating in financing some projects from the consumers to be more sustainable. This is something like we call regenerative finance, but it's something like a crowdfunding to the producer to be more sustainable and to give more and better information to the consumers. Next slide. So the benefits for farmers and producers of all of these, and aligned with answering the first question that I said, the problems that they have in the day-to-day operation is we can contribute to give more data, more information, more insights to increase the operational efficiency. So it will be an impact, a direct impact in the operational efficiency on the day-to-day activities from the farmers and food producers. By giving them some of the information on sustainability measures, sustainability, and answering all of these demand from the consumers, we enable them to have better consumer engagement. So we increase the loyalty from the consumers to that brand, as we saw in the first slide. And then, of course, by the traceability and the traceability from farm to fork, we enhance this transparency and we increase the trust from the consumer. And this is what we think that it will be enabling those consumers and those farmers to answer this current demand. And that's it. Thank you very much.
Israel, thank you very much for this wonderful presentation.
Yeah, thank you.
So again, highlighting, if anyone has questions, please use the Q&A section. We have already one question ready for Rebecca, to which we will get on soon. But keeping in mind the time, we will move to the last speaker. Glad to welcome Jose Maria Alonso Rodriguez, Cacho, who is Innovation Coordinator at Soltec Ingenieros. And he will delve into implementing a digital twin tool to enhance decision-making in agri-food value chain, and presenting the BBTWINS digital twin toolbox and its unique functionalities. So Cacho, happy to give the floor to you.
Okay, thank you, Daria. So in this last presentation, we are going to show you some examples, let's say functionalities, short videos of what we call the BBTWINS digital twin toolbox. We will start with the functionalities of the digital twin of Natural, which is the pork value chain, from the feed mill to the curing facilities, different examples. And then we will go through some examples of functionalities developed in the use case of Dimitra, which is the pitch value chain. So let's go. Next slide, please. Okay, this is the first example. This is the feed mill digital twin. This is a tool or a part of our toolbox regarding the first step of the pork use case. If you pass to the next slide, I can explain a little bit let's say the integration diagram. This is part of how we integrate the developments of different partners of the project. So Panimagen has launched an open route service, which is the maps in the cloud, so we can consult different distances between points or between farms or similar. BTT from Finland, the partners who have developed the models, the mathematical models in Python to optimize the routes, the logistic routes. And finally, we have integrated all these previous developments in the digital twin. So in the next slide, we can see a video regarding how this is integrated. So please play, please. So start moving. Okay. Here we can see the three different areas in the digital twin. In the left area, we can see the inputs can be modified through directly in the different cells or through Excel or similar. In the central area, we can see the 3D model, but also with KPIs, dashboards, graphs, where we can see information regarding the simulation with the scenarios that we are launching with the digital twin. And in the right side, we can see the output, so are the results of the simulations. Regarding this digital twin, we are working in logistic optimization and also in improving the planification in the feed mill, in the factory. Next slide, please. We go to the next step of the value chain. This is the same. This is the same one. Okay, here is the fattening farms digital twin. Next slide, please. Here, I think it's a video. You can, okay. Here we have info from the different farms. So we face what Panimagen, what Rebecca showed us before, that was the cloud point with the LiDAR laser of the real growth of the porks, and we put this info versus the theoretical rate of growth of the porks. So we can know if this farm is growing accordingly to proper parameters or not, and this information can be shown also to the feed mill, so they can modify the ingredients of the feed, and also to the slaughterhouse, so they can know when these pigs will be ready to be sent to the next step of the value chain. Next slide, please. Okay, here is the next step of the value chain, which is the Cartesa slaughterhouse. We have next slide, please. We have also a video regarding the production planification. Here we have different inputs regarding different products that we can obtain from the porks, the available animals in the slaughterhouse every day, the resources that we need in the slaughterhouse, and the client's orders. So we have to match all of this. For example, this is the matrix of the workers. We put all of this information inside the digital twin and make the planning of the day, the production planning. This is a view of the cloud where all the information is sent by in this case by Cartesa, by the production plant, and we work in the digital twin with this day-to-day data. Then we can see in the digital twin, in the 3D model, the different parameters, different KPIs, and different graphs of the production of both from what's happening today and the simulation scenarios also. Here is also integrated info that Rebecca told us before also. For example, the thickness of the fat of the carcasses of the porks is needed to organize the production. Depends of the thickness. It will be a kind of product or another kind of product. These are restrictions for the simulation. So we take this into account to organize the day-to-day production. We have different resources as the number of workers, the numbers, the sex, and the weight of the different pigs. So we can organize all the orders in a day-to-day planning. We have also different ways of watching the results and the quantity of auxiliary materials, the energy consumption in different areas of the company, different production lines, the efficiency of the lines, the cost, a layer of costs of different materials or different raw materials that we need to fulfill these orders. And once again, this is a view of the cloud. So the result of the simulations, in this case, the planning of the production of this day is sent again to the cloud. So the final users can see directly the planning. Next slide, please. And this is the last use case in the pork value chain, that is the ham drying facilities, the curing facilities. Next slide, please. Here, the objective is to reorganize the chambers so we make the minimum spend of energy. Why? Because smaller hams, they have to stay less time in the chambers, so we have a energy saving directly there. Nowadays, every day they just introduce the hams in different chambers without taking account the time of curing. We can simulate all of this, and we have done it connecting the digital twin with the models that Cetic has developed in console regarding the time of curing, depending of the weight and the size of the different jams and shoulders. This is the view of the console simulation regarding the time of curing of these products. Okay, next slide, please. This was the last one for the pork value chain. And now we will see the fruit use case, the Dimitra facilities and also the logistic optimization. Next slide, please. Regarding these functionalities, we have something important to define these functionalities in the first steps of the project with the final users. In this case, we were working in optimization of the box lining in the storage. occupation planning, the raw materials consumption calculations, both raw materials, the quantity and the cost, and the power consumption of the company. Next slide, please. This is a video. Okay. So we have different input parameters. These are different varieties of peaches and nectarines. We know the quantities that are going to arrive every day to the company, and according to this, we calculate the energy that is needed, the quantities of raw materials and different materials as boxes or plastics or film that is needed to fulfill this quantity of peaches that are arriving this day. We can calculate both logistics emissions or logistic routes, and also the optimize the production inside the production plant. They have a sorting line, they have different chambers for different products. We know the different materials that we need to fulfill the production of the day, and also the energy that is spent in every step of the production line. We also know different costs, both the cost that is paid to the farmers and also to inner cost, personal cost, energy cost, and so on. And we can modify this directly in the simulation environment. Here in the left column, let's say in the inputs column, you can modify the quantity of peaches per box, or the price of the energy, or launch different simulations, what-if scenarios. We have also different KPIs or different dashboards in the 3D model, so you can visualize very easily this information, this data over the digital twin in the 3D area. And yes, let's let it go ahead, because in the next functionality, this is in the same video, is the optimizing the logistics routes from the crops, from the fields to the sorting facilities, so they can plan, make a better planning of the resources for everyday work. Here are the results of what happened with different qualities, with different sizes of the peaches that they obtained in I think it was like a 22 days simulation. And now we will launch here. We can just launch the open room service. So depending of the planning for the next day, we will give to the trackers the optimal route to bring to the sorting facilities, to the Dimitra sorting facilities, the peaches, the fruit. And that's all from my side. Sorry. Any doubt or similar, we will go through it.
Cacho, thank you very much for this very detailed presentation. The videos were definitely very helpful, since it really is complex. So thank you. Now all the speakers have spoken, done their presentation, and we are ready for the Q&A part. So I can see we have already in our Zoom Q&A part, we have 7 questions. And I think I will start with the last 2 questions, Cacho, to you, from Jens Slotmans. So the first question, no, actually 3 questions from Jens. So which sensors or data inputs are required to run the digital twin model simulations?
Well, in fact, it's not absolutely necessary to have prior data, let's say historical data or data from sensors. If they are available, the model will be more accurate, let's say. But if there are not data available or data from sensor, we can make a mathematical or statistical modeling to start feeding the digital twin, let's say, and when the data is obtained, or once we can validate if our model is working properly or not, the model can be, let's say, fine-tuned with this new data. So if we have historical data or data from sensor, is great, because we will have a first approach quite accurate. But if not, this digital twin can also be done by, let's say, mathematical or statistical or even time studies. So both ways are feasible.
Okay, got it. Next question from Jens. Does the digital twin need to be changed for each facility, e.g. for every pig farm or of pig slaughter house?
Yes, let's say that in part it have to be adapted, because two different farms are not always 100% exactly the same. But two farms, I think that over 60 or 70% of work is done. So you just have to adapt to maybe the number of pigs, or the surface available, or the number of silos for feed or similar. But let's say that the core model is the same. It just have to be adapted.
Okay, thank you. And last question from Jens. Which software was used to create the 3D models for the digital twins?
The software was our development, but it can be also done or downloaded, for example, in standard software as SketchUp or similar. In our case, we use our own, but it can be say, interpreted with different standards.
Okay, got it. Thank you. And actually, I see another question that is for you. So the question is it necessary to have prior information and historical data to develop a digital twin?
Well, in part, I answered it before, because it's not necessary to have, it's not absolutely necessary. It will improve the accuracy at the beginning, but we can make it in let's say, a mathematical model or a statistical model without data. Of course, it will be great or will more accurate the model if we have historical data 2-3 years. But if not, it also can be done as well.
Great. Okay. Thank you. Thank you, Cacho. So now there's also questions for Rebecca. So Rebecca, the first question is, what are some specific examples of how the implementation of AI technologies has improved productivity on farms and efficiency in food production?
Yes, one example, maybe in precision agriculture, maybe is the implementation of AI-powered predictive analytics, because by analyzing data collected from sensors and satellites, farmers can optimize irrigation schedules, leading to water conservation and increase crop yields, and all contribute positively to the environment. So I think is one example.
Okay, great, thank you. And another question for you, Rebecca, is what specific measures do you take to ensure the security and privacy of data collected from the sensors and cameras used in the field? And do you have an organizational data governance program or something similar?
Yes, compliance with data protection regulations is really important. Therefore, we take care of to restrict access and store information in a secure way. For example, in this project, the data lake that we are using in the cloud is only allowed for the people in the project, leaving them fully protected. So we try to follow the established regulations.
Okay, great. Thank you.
Thank you.
Do we have any more questions? All right, you can use the Q&A part to ask your questions if you have. But I would have one question for Mr. Israel Serrano. Israel. So you did touch upon this topic before, but just want to ask this again. So as the CEO and the founder, could you elaborate on the role of the blockchain technology in ensuring traceability and transparency in the agri-food supply chain, and how it aligns with the European Union's strategic goals?
Well, the technology enables you to have the whole information of the value chain in one single place. What it means that blockchain technology allows you to have only one copy of the data, but in distributed, let's say, ledger. That's a really important step. So everything will depend on the ability to every of the stakeholders on the value chain to keep and save the data on those, let's say, blockchain-based solutions, and then everybody will see the same information. So basically, you don't have silos of information in the farmer, another piece of information in the producer, in the production or manufacturer company of the food. You don't have another piece of information in the logistics. So they are sharing the same information. The second important thing is shared securely, because the blockchain technology or the distributed ledger technology is based on cryptographic functions. So it makes by default that the information is stored in this persistence layer, in these special databases, or in this special ledger are encrypted. The third thing, as I mentioned before, in a normal database, you can read, write, edit a record, or delete it. Only typically the admins can do that, but it's possible. In a blockchain, you cannot. You can only read or write. So what it prevents the information stored in this system, in this persistence layer, to be prevented for this manipulation from some actors, in the value chain. So for instance, it may prevent when a producer or a brand is releasing some of the food, and they say, okay, we have 2,000 of ribs here, and it will be rotten if we don't sell it. And they decided unilaterally extended the expiration date for 1 year or 6 months more. They are manipulating the data, and it can cause some of the food alerts. I don't want to be more specific, but it happens in Europe a few years ago when a brand manipulated some pork food, and they changed the expiration date, and it was a food alert because that food was already rotten. And with this technology, you can prevent this manipulation of the data. Can be intentional or can be unintentional, so can be just happening because of failure in the system. This technology will prevent you to have this manipulation of the data, and all the people, all the stakeholders in the value chain will see the same information, because the data is replicated within the special databases that are the ledgers.
Mm-hmm. Okay, very good. Very good. Thank you, Israel, for answering this question. So we are starting to wrap up But before, I see there's one more question in the Q&A chat box. So this is a question for Cacho. In general, what steps need to be taken to develop a successful digital twin?
Yeah. Okay. Yes, in our experience, there are some steps that are very important. The first step is to understand the needs and the process and define the functionalities with the users. Why they want to use a digital twin and what's the objective? Is a planning objectives? Is a predictive maintenance object or resource optimization? This is very important to define it at the first step with the user, not only with the, let's say, with the owner of the company, but with the real user of the tool, with the production manager or the line manager of the factory. It's also very important then to define the data sources of these mathematical models that have to be generated to be able to launch these simulation scenarios. If we, as I said before, if we have historical data or data from sensor is great, but if not, it can also be done, let's say, manually, studying these processes and understanding the processes on site with real visits and measuring the different processes. Then we have to make at the same time we can make the 3D model, because the 3D model are just for visualization purposes. So it can be done in parallel with this mathematical model generation. And when these models are fulfilled more or less 90% of the reality, so we have to check if this theoretical model of this digital model fits the reality. Once it fits quite well, we integrate everything and validate with the users, and then start the fine-tuning. The fine-tuning can be maybe 3-4 months with real data from the factory, and making this the fine-tuning of the digital model to be as near as possible from the reality.
Perfect. Thank you for this very good answer. All right, so we will wrap up this event, but before we do, Daniel, Rebecca, Isra, Cacho, is there anything else you would like to, from your side, mention as the last word? All right. I just want to say that this event is to foster collaborations. So you have the information of all the speakers. So please feel free to reach out to them if you have any more questions, again, to foster any collaborations in this field. So from our side, thank you very much, and hope to see you soon.
Thank you.
Thank you.
Thank you very much, guys. Yeah.
Have a lovely day.
Thank you.
Bye-bye.